This module is brought to you by Battelle for Kids, the oak tree analogy. This module will bring to life a conceptual analogy about value-added analysis. In this analogy, we will look at concepts of achievement, growth, and value-added. The learning goal for this module is to gain a conceptual understanding of how value-added modeling works. In this analogy, we will be explaining the concept of value-added analysis by observing the performance of two gardeners. For the past year, these gardeners have been tending to their oak trees, trying to maximize the height of each tree. Each gardener uses a variety of strategies to help their own tree grow. We want to learn which of these two gardeners was more successful with their strategies. To measure the performance of gardeners, we will measure the height of the trees today, 1 year after they began tending to the trees. With a height of 61 inches for oak tree A and 72 inches for oak tree B, we find gardener B to be the more effective gardener. This method is analogous to using an achievement model to evaluate performance. But this achievement result does not tell the whole story. More data is needed. These gardeners did not start with acorns. The trees are 4 years old at this point. We need to find the starting height for each tree in order to more fairly understand each gardener's performance during the past year. Looking back at our yearly record, we can see that the trees were much shorter last year. We can compare the height of trees 1 year ago to the height today. By finding the difference between these heights, we can determine how many inches the trees grew during the year of gardener's care. By using this method, gardener A's tree grew 14 inches, while gardener B's tree grew 20 inches. Oak tree B had more growth this year, so gardener B is the more effective gardener. This is analogous to using a simple growth model. But this growth model does not tell the entire story either. We do not know how much of this growth was due to the strategies used by the gardeners themselves. This is an apples to oranges comparison. What might be some environmental factors that are out of the garden's control? For this example, we will look at rainfall, temperature, and soil richness. Based on the data for our trees, we can see what kind of external conditions the trees experienced. The data tell us that oak tree A was in a region with high rainfall, low soil richness, and high temperatures. Oak tree B was in a region with low rainfall, high soil richness, and low temperature. We can use this information to calculate a predicted height for each tree today if it was being cared for by an average gardener in the area. We examine all oak trees in the region to find an average height improvement for trees. Then we adjust this prediction for the effect of each tree's environmental conditions. We compare the actual height of the trees to their predicted heights to determine if the gardener's effect was above or below average. Remember, to make our initial prediction, we use the average height improvement for all trees. Based on our data, the average improvement for oak trees in the region was 20 inches during the past year. We start with the tree's height at age 3, add 20 inches for our initial prediction. From the data we collected from our region, we find that more rainfall and higher soil richness contributed positively to growth. Higher temperatures contributed negatively to growth. With those growth trends, we need to convert them into a form usable for our predictions. For example, we found that oak trees that experienced low rainfall tended to have 5 fewer inches of growth compared to the average oak tree in the region. Trees with medium rainfall tended to have 2 fewer inches of growth, and trees with high amounts of rainfall tended to have 3 more inches of growth compared to the average. This table shows the adjustments made for all 3 environmental conditions. Since oak tree A had high rainfall, low soil richness, and high temperature, we adjusted the initial prediction of 20 inches by adding 3 inches, subtracting 3 inches, and subtracting 8 inches again to compensate. The same process was conducted for oak tree B. Once we have refined our predictions based on the effect of environmental conditions, our gardeners are on a level playing field. The adjusted predicted height for oak trees in oak A's condition is 59 inches. The adjusted predicted height for trees in oak B's conditions is 74 inches. This is an apples-to-apples comparison. When we compare the actual height of the trees to our predictions, we find that oak tree A's actual height of 61 inches is 2 inches more than we predicted. We attribute this above-average result to the effect of gardener A. Oak B's condition, oak B's actual height of 72 inches is 2 inches less than we predicted. We attribute this below-average result to the effect of gardener B. To get a clear sense of each gardener's effectiveness, we need to look at all of the trees in their care during the last year. This is analogous to a value-added model. Now, who is the most effective gardener? As we move into more specifics about the Pittsburgh Public Schools value-added model, let's try to apply the concept of predictors in the education context. On this slide, you see a list of predictors that have been considered in the PPS model. Each control variable is tested for whether it increases the predictive power of the model. Control variables that increase the predictive power are included in order to make the value-added model as accurate as possible. Just like the environmental factors of rain, temperature, and soil richness, this list of variables have proven to increase the predictive power in PPS. Pittsburgh Public Schools is taking every precaution to ensure that the data used for the model is consistent and precise. This is why multi-year measurements are being used. In addition, PPS is using a dosage measure that captures the exposure of the student to instruction by the teacher or school. Principals and teachers will be asked to verify student rosters twice a year. This process will ensure that students and teachers are properly linked for accurate progress attribution. Please note that this is not a simple calculation. Students are predicted to be at the district average compared to other students like them in the district. The graphs that you see are conceptual interpretations of using predictions. If students perform higher than predicted, then value-added estimates suggest the teacher or school contributed positively to student learning. If students perform lower than predicted, the value-added estimates suggest the teacher or school underperformed against the district prediction. This does not mean that students were not learning. It simply means that the effectiveness of the school or teacher was below the district average. These predictions and results can be provided for various subjects and grades throughout the district for schools and for teachers. In closing, let's pause and reflect on a few questions to help you process your thinking about the PPS value-added model. What are your hopes for value-added? Now, what are your fears? Last, Please respond to the prompts on this slide. You can do this individually or as a team. This concludes this module. In the next module, you will learn how to interpret the information on the PPS value-added reports.